So if you struggled on this one, go ahead and follow along with me so you know how to do it coming up. So it says solve for n, and so this, we recognize that this is a quadratic when the highest power of the variable is a 2, then it's a quadratic. And we have various methods for solving those. Because there's this term, we call that the bx term. It means we're going to try to factor. If that wasn't there, so just for a second, if that wasn't there, we could solve this by square rooting, which is a little shorter. But with that, we need to try to factor. First step, set equal to 0. And that means I need to subtract 5 from both sides. So when I say set it equal to 0, we can't just like change something and make it 0. But we need to algebraically make one side of the equation 0. And now this should look like, well, the left side should look like the factoring that we've been doing on the factoring packet. Are you with me? Okay. Alright, so then step 2 is try to factor. So we're going to do our star. This does factor. When I say try, I don't mean this one doesn't. But sometimes they don't. Anybody know what you do if it doesn't factor? So we would use the quadratic formula, and it always works, but it's not always the best way. So A is 1, C is 10, and so that gives us just 10. B is 7, and then like I said, A is 1. Okay, are there factors of 10 that add up to 7? All of them. 2 and 5. Awesome. So 2 and 5. Okay, then we check to see if these two sides can be reduced. I'm going to put a couple reminders over here. Don't forget to check for GCF and reduce. But these two are already simplified all the way, so we're good. Alright, so x plus 2, remember top number with x, bottom number you just write with the sign. So x plus 2, x plus 5. If you wrote 1x, that's also okay. Okay, but notice this time this 0 still is on there, so we can't forget that we're solving and leave that 0 on there. Okay, so we're good there. We have factored. And then here's the step that I reviewed yesterday. Steven's having some trouble. Solve by setting each factor equal to 0. Each factor is the 2 parentheses. So this is where I tell students to just sort of separate the two. And we'll say x plus 2 equals 0 and x plus 5 equals 0. And then just solve those. Those are usually like 1 or 2 step equations. So in this case, subtract to get the variable by itself. Minus 2, minus 5. And often you'll be able to look at these and know exactly what it is. Like looking at this, we know it's going to be negative 2. And then over here, it's going to be negative 5. So there's our 2 solutions for that. How'd you do? Okay. So hopefully if you didn't get this, you didn't remember, you wrote it down so that next time you can, and you'll just kind of start picking this up as we get into it. And this will be part of our geometry solving, as you sort of saw yesterday. Okay. Speaking of that, let's review. So grab your notes wherever you're writing your notes, and let's review the segment addition postulate and some of our vocabulary. So we started writing some notation. yesterday, and big ones that you definitely need to know is the segment notation, which is just a line with no arrows above the 2 letters. Angle notation, we're going to talk the angle addition postulate today. So the angle, remember, was named with 3 letters, the vertex letter being the middle letter. So like this angle we didn't label, but it would be either ABC or CBA. But either way, the B needs to be in the middle of the letters. And we saw this kind of tipped over L looking thing for the angle symbol. And then we talked about our first functional relationship, which was the segment addition postulate. And all it said was if we add up pieces of a line, it equals the total. So we're going to see that in action today. We will be writing an example in your notes, so let's go ahead and put one in there. I'll give you a second to write that down. And it probably would be helpful to tell yourself this is segment addition postulate. So remember the segment addition postulate is telling us that each piece added together adds up to the total. So in this case, that's going to look like, well, let's write a step name, a step description. Set up an equation by writing a total. Actually, let's put a word in front of that. By writing an expression, this will be more general, for the total on each side. And then step 2 is just going to be solve the equation. Step 3, if we need to, we might have to plug back in. But that's problem dependent. Plug back in as needed. Okay. Very typical process. Geometry, relationship sets up an equation that we solve and then sometimes plug back in. So, take a second to get those steps and then we'll follow them to do our example. This one is pretty straightforward. Some of the ones we'll do won't be quite as much, but this strategy for number 1 will be good for all of those. So that first step is really important. So if we look here, we see that NM plus ML plus LK equals NK. In other words, part of the way plus part of the way plus part of the way equals the whole way across this segment. Now we just substitute in the different expressions for each of those. So NM is x minus 6. ML is 9. LK is 2x minus 19. And NK is 23. So we just did step 1. We set up an equation by writing an expression for the total. I forgot the word the. For the total on each side. So this whole side is the total length, and so is that side. Now we solve. So fairly basic solving. x plus 2x is 3x. Then we have negative 6 plus 9, which is 3, minus 19, which is negative 16. And then from here we just get x by itself. So we're adding 16 to both sides. Let's get some more room. Chronic writer, too big of writer. Oh well. Then we divide, we get 13. Okay, so x is 13. Now the problem here doesn't say solve for like nm or something, but in terms of number 3, that's what we would do. In fact, let's just put that on there. Let's say we wanted to know the length of nm. What would we do with 13? Alright, go ahead and have a seat. What would we do with 13 to get the length of nm? Plug it back in for x, okay? So this would go back here for x. So x minus 6 equals 13 minus 6. So that length would be 7. If it asked for solving for that, if it asked for LK, we would do the same thing with the x there. So, what do you think? Segment addition. Does the base concept seem to click? So here's some examples. We're going to do these couple pretty fast, just for a concept demonstration. So it shows us that this segment, g to I, is 7, and it says find hj. So we're asked to find that segment. So h to I we need in order to add hi plus ij. So here's what in terms of our notes, hj equals hi plus ij. So there's our statement of piece plus piece equals total. Well, we don't know how long hj is. How long is hi? Just say it. Just shout it out. If we know gi is 7 and gh is part of that, and 2 is 2, what is hi? It's 5. That technically uses the segment addition postulate as well, but I figure it's easy enough to see. I'm not going to write it down. Okay, and then it tells us ij is 12. So how big is hj? Okay. So that was kind of an easy one. Now this one, still just numbers. There's no x's involved, but we do have some overlap, and so that makes us have to be more careful. So in other words, like this piece overlaps part of that piece when we have overlap.
Subtract the part of the length that you know.
Yeah. So we can't double count that overlap, so we do have to subtract there. Okay, so again, this time we have a total. So this is one expression for the total. So that equals 49. Actually, let's write this first in all letters. So what are we finding here? ik, so I to k. Alright, here's how I would write this. ik gets us to there, plus, do you see how this 31 starts at j? So ik plus jl minus this little piece that's getting double counted, minus jk, equals the total, which is il. So here's what we did. We started walking at I, we walked over to k, dropped back here, and doing that we are now re-walking j to k, and then we walk to the end. So that little backtrack piece is something we have to subtract, otherwise we walked it, and then we're walking it twice, and that's double counting it. So Eva said subtract it. That's why we subtracted JK off. Anyway, and then that equals the whole way across, which was IL. So now we plug in numbers. IL was 49. JK is 12. JL is 49. And so, no, sorry, it's 31, not 48. And then IK, we don't know. So you can make it an X or just leave it as IK if you want to keep it clear. So 31 minus 12, subtract that from 49. What's 31 minus 12? I'm going to move up here. You guys are really, really, really quiet. 31 minus 12. Do it in your head. Or on a calculator. Brian, what's 31 minus 12? 19. Thanks. You knew it. Alright, subtract that, and IK is 30. Okay, and then you can plug that back in and make sure it works. Like 30 plus 49 is 79, and then minus 12. I keep adding the wrong thing. 30 plus 31 minus 12. There we go. And that's 49. So, that's the version when you have a picture. Here's an example or two of ones that don't have a picture. So, points A, B, and C are collinear. Do you remember what that word means? We wrote it in your notes yesterday. How many of you are studying your notes? Raise your hand. Okay. Yesterday we started adding to them with geometry concepts, so you've got to start studying those notes. Collinear means on the same line, so draw a line. It says A, B, and C are collinear with B between A and C. So it does not matter where in there you put B, it just has to be in the middle. So there's the representative picture. Now we are given some information to label. So you need to draw a picture and then label. So AC is 3x plus 3. I would do kind of like the pictures up there. This one is all the way across. AB is negative 1 plus 2x. I would just stick that right on top of AB. And then BC is 11. It says solve for x. With the picture now, I think it's pretty clear what we do, hopefully. So we know AB plus BC equals AC. This one comes straight off our theorem or our postulate in our notes. Well, AB is negative 1 plus 2x. BC is 11. And then AC is 3x plus 3. Solve for x. So we get 2x plus 10 on the left. And then combine our terms across the equal sign. We'll get x. So subtract 2x. Subtract 3. And those cancel. And those cancel. And then we'll get 7. So just a couple of different versions of how these run. I want you to try these, please, and see how they go. Let's try these bottom two. Notice the prompt says find the total length, so not just x. This one does just say find x. So I'm going to give you, I don't know, 6 minutes or so, maybe a little bit more. Let's see if we can knock those out. Please ask for help if you don't get it. Guys, think about, we want to get all the way across this line in 2 different ways. So in the note, we said set up an equation by writing an expression for the total on each side. So an equation meaning it has an equal sign, and we need a total distance on each side. Well, let's let's recognize that this blue line is the total distance. It starts at S and ends at V. That's 4x minus 29. So that's a total. And then the other total, let's see, in the circle, and the other total is this. S to T, that's 13. And then T to U, that's 6. And then U to V, that's 2x minus 18. And that's the other total distance across. And now we have our equation. We can step out of geometry mindset and into algebra. So we have 13 plus 6 is 19. That side didn't change. 19 minus 18 is 1. And so we get, move this down, this becomes 2x plus 1, and then equals the other total, 4x minus 29. And then how about solving from there? Well, get your x's together. That would be minus 2x minus 2x. Let's get our constants together, and that would be plus 29 plus 29. And those cancel and those cancel. And we are here at 2x. That should say minus. Let me fix it. 2x equals 30, so x equals 15. It says find the total length. How do we do that? Because we have x. X is not the answer to the whole problem. Yeah, Parker?
Plug 15 into x.
Yes. So this, for total length, I would plug it in right there for 29, or for x, I mean, excuse me. Plug 15 right there, and we'll get 60 minus 29, which is 31. How'd that one go for you? So it's geometry to set up an equation, algebra to solve it, and then like this one we had to go back to geometry to get the total length. Did anybody get this one? Okay. Let's talk through it. Again, we want some version of total equals total. That's what our notes say. So we need to get a total length two different ways. Here's one way. If I start at B, I have an expression for B over to C. That's 3x plus 47. Okay, and then from B, or excuse me, from C, do you see how I have a gap right here? I don't know that distance, so I have to pick up somewhere else where I know another expression. So do you see how we have to drop down here? And we can pick up at C and go the rest of the way? That's a total. So now we have 3x plus 47 plus dropping down here plus x plus 26. That's all the way across. So we have now made a total. Okay. Other version, starting here at B but on a different spot, and we get all the way to D. I can't drop down here because how far did I go across x plus 26? We don't know. So where do we go instead? Go up, and I see that starting at D, I know that it's 10. So that is going to be 27 plus x plus 10. That's also a total. So it gets me all the way across. And now we have a regular old algebraic equation to solve. If you haven't solved that, I'm going to give you about half a minute. Okay, over here we're going to combine our like terms. So we have 3x and x, that makes 4x. 47 and 26 makes 73. Over here we have 27 and 10. So 37. Okay, what's a good next step? We need to get these x's. So subtract that x, subtract this x. We'll get 3x. Subtract 73. Okay, here's a good reason to have one. Now we could do that, but this is faster. So negative 36. Divide by 3, and we get negative 12. Now, this is kind of weird. X is negative 12. Can we have a negative answer in geometry? Thinking about the fact that we're talking about segments. Okay, so be careful. This is a really important thing. In fact, on your paper, I want you to write this. X can be negative. That's okay. If, and this is a big if lengths, well, let's be more specific. If it doesn't make lengths or angles negative. So does it? If we have a negative 12, does any of the segments become negative? Go back and check. So look at your problem. Knowing now that x is negative 12, are any of these pieces going to be negative? Because if they are, something's wrong. In geometry, we can't have that. So is this one negative? If we plug in negative 12? Is this one? Is this one? So they're all okay, right? In this case. But sometimes you need to be careful and say, no, that doesn't work. All right, put that away for a second, and we're going to talk angle addition. You're going to have more practice with these here in a bit, but let's talk angle addition. So let's do the same thing for angles. Grab your note packet. We're going to write the theorem. Actually, it's a postulate for that. It's called the same basic thing, it's just with an angle instead of side length. So angle addition postulate. Remember, a postulate is a statement that's assumed to be true. We'll call this AAP. What do you, if I told you it's basically the same idea for angles, what do you think it's going to sound like? If we said piece plus piece plus piece, etc., equals the total for segments. How about this one? Have you ever opened a door to look out your door and then opened it farther? Yeah, you have, I'm sure. Or opened the car door a little ways and then shoved it open to get in or whatever. That's this. If we open it a little, that makes some angle, and then open it more, that makes another angle, and the total is just the sum of those two. So draw a couple angles. Of course, we need to put labels on all these. And you'll need to remember your naming rules for angles. So our postulate says this: measure of angle ABC. So that's this first one, ABC, plus measure of angle. What's the name of this bottom angle? I'll put a dot in there. What's the name of that angle? CBD. Yep. Equals measure of angle, and then the name of the whole thing. So if we open the door a little ways and then open it farther, that whole angle is the total. And that in this case is ABD. So ABD. Okay? Basically the same idea. It's like angle piece plus angle piece etc., because we could have more than 3, equals total angle measure. Definitely could have more than 2 making this up. Okay? So I think once you get the concept of the segment, it makes sense to just shift it over to the angles. You don't need that on. Can you put it in your backpack? Any questions on angle addition postulate theory concept? We good on that? Okay. So here's a protractor. Have you ever used one before? We will have a chance to use them, but just not quite yet. Okay, so look, I see 1, 2, 3 small angles plus a total. So those 3 little angles have to add up to the total angle. And how do we read? So let's do this first one. This is measure of angle AEB. How do we read the measure of that angle in a protractor? Because I see 2 rows of numbers. Which one do we use? What was it? In this case, it's the top one. How do we know to use the top? How did you decide?
I just picked
You did? Okay.
Yeah.
Well, let's be clear on what these say. Like if we use the top one, that would say like 47. If we use the bottom one, that's like 133. So if we're talking about this angle right here, should it be 47 or 133?
47.
How come?
Because 133 is way too big for that.
Yeah, you remember the words acute and obtuse? So when you use a protractor, you just look at the series of numbers that tells you if it's going to be acute or obtuse. And in this case, we know this is acute. It's smaller than 90, so we better use the 47 and not the 133. Okay, so this is 47 degrees. Now, for this next one, it's between 2 numbers. Right? So it starts at 47 and it goes to 105. So how many is that? What, between 105 and 47? Why don't you grab a calculator and punch it in? Because there's a lot of just kind of sit and get. Grab your calculator, be part of this, answer questions. It's going to help you, I promise. If you just sit there, it doesn't work as well. 105 over here, and this is 47. How big is that angle? It's 58 degrees. Okay, and then we need to do a similar process here. We're at 130 and 105. That one's kind of easy. That's 25 degrees. So 130 minus 105. So 25 degrees. Okay, if we add these up, so grab your calculator and add up 47 plus 58 plus 25. Now we should end up at 130. Okay? So piece plus piece plus piece equals total angle. And I think it's easy to think of this like looking down on a door. Hey, I open it up, and then maybe it kind of swings open and eventually all the way. Okay? That's a visual. It's nice on here. It's like using a ruler. It's a visual for angles. Okay, let's look at. I think you have this. Will you flip your yeah, I have it on your packet. Flip over. No, these start on number 11. Let's see if I have those. There's some. 13. Yeah. So go to those. Second page. 13. Let's do 1 or 2 just to give you an example. So do it with me on your paper. Okay, it says measure of angle FCD is x plus 41. So that goes right there, x plus 41. And then angle BCF is x plus 78. That's that one right there. And it tells us the measure of BCD, the whole thing, is 95 degrees. So it's kind of hard to show that sometimes when you have all your notation, but that whole angle is 95 degrees. So using the angle addition postulate, what equation can we write in order to solve for x? Well, piece plus piece equals total. So x plus 78 plus, that was one piece, the top one, plus the bottom piece equals 95, the whole angle. Okay, and then we have our little equation to solve. Gives us 2x, and then what is that? 110, 119, I think. Okay? 2x equals negative 24, and x equals negative 12. Again, we need to check, because we got a negative answer. Is a negative 12 okay? Well, you tell me. Does it make any of those angles negative? No, we're good. Okay? Alright, similarly, down here we have kind of a weird angle. So, measure of angle GFZ is 38. So, GFZ, that is 38 right there. ZFE is 2x plus 125. And GFE, that is the whole thing, which is darn near 180 degrees. That whole angle, this time is not known but has an expression. So 160, x plus 163. Okay, so we have two pieces again adding up to a total. 2x plus 125, that's piece 1, plus 38, that's piece 2, equals x plus 163, that's our total. So piece plus piece equals total, total equals total, that's another way to say it. So we have 2x, 125 and 38 is 163, I think. Yeah, so x is 0. Okay, questions on angle addition postulate? So you see how it's just the same? Now we're just going around at angles instead of along a segment length. Obviously, if we twist these around, we can make these problems a little bit harder, but not too bad. So on your packet, let's do a couple of these as well. On that same page, circle number 20. I'm going to give you a few minutes to work on these. Circle number 20, and then on this page, which would be page 3 in your little packet, I want you to circle 26, 27, and 28, please. So try number 20. Give you a little bit to do. Okay, so here's your setup for number 20. Again, label your pictures. They're way more useful with information put in them instead of just reading it out of text. Okay, hopefully you can see if I start here on line FG and I open a little and then open further, it's going to be adding the two red angles. So 4x plus 10 plus 14x plus 3. That's one total. And now we need another total. In this case, it just straight told us that it was 157 all the way open. Okay, we solve that real quick. And we get 18x plus 13. On the left, when we combine our like terms, subtract 13. And we'll get 18x and 144. And well, that's weird. My screen is dark on this thing. and we'll get 8. Okay, but this problem asks you to solve for angle NFE. What do we do there? Yeah, I think.
Plug in the x for the angle.
Yeah, so in NFE, we have to plug x in right there by the 14. So measure of angle NFE equals 14 times 8 plus 3. So 14 times 4, so that's 112, 115 degrees. Okay. How'd you do on 20? On the other ones, like 26, 27, 28, you have the same picture. Each problem starts new. So sometimes students get confused and think that you kind of like build on the problem, but just start over for each number. Again, put it in the picture. Just take a second to sketch the 3 angles, actually 4 angles, and then fill it in each time. I promise that will help if you label your pictures. All right. Last thing, we're going to talk, you're going to get practice on this between now and Friday. Last thing we're going to talk about is some notation for a word called congruence. So back to your note packet. It's another way of letting us work quickly and efficiently without having to write a bunch out. So first we need to define this word, congruent. We're going to use this word a ton this year. So today, like by Friday, have it memorized, please. The word congruent means exactly the same size and shape. So exactly the same size and shape. Initially, we're going to just talk about exactly the same size. And then in the next unit, we'll get into also the same shape. The symbol for congruent is an equal sign with a tilde above it. Okay, so you're going to see this symbol a whole bunch this year. Equals with the tilde for congruent. So that's how we write things are congruent. So if you want to put this like example statement, what would that say in English? Even though it's hardly any writing, it actually has quite a few words in English. Give it a shot, Eva.
AB is congruent to CD.
Yeah. And specifically segment. Yeah, good job. So segment or side length, if we're talking like in a triangle or rectangle or something. Segment AB is congruent to segment CD. See how nice it is? Like I would not want to write that out every time. So let's use symbols and notation. Now, in terms of seeing congruent notation in figures, I think it makes pretty good sense once you've seen it once or twice. So draw 2 triangles that look roughly the same. And we'll label this first one ABC, and then the second one we'll label DEF. Okay, we're labeling the vertex points, the vertices. You're going to really appreciate this because I can communicate to you a lot of information without having to read it all. It's just, it can be put right in the figure. Oh, you're missing out on stuff. Can you focus, Morgan? Okay. Next, you're going to put 1 tick mark on the left sides, 2 tick marks on the bottom, and 3 tick marks on the right. Okay. Use tick marks to show congruent lengths. I'm going to use the symbol because I don't want to write that word. Use tick marks to show congruent lengths. The same number of tick marks means they're congruent. Means congruent. So which sides are congruent in here? In our figure. Like,
All of them?
no, they're not all congruent. That would imply they're all congruent or equal to each other, right? So here, AB is congruent to what? ED or DE. If we're being specific, it would be DE. That's the same order. Okay, give me another pair based on the notation. Okay, I think I heard BC and what? EF. And this is all just because of notation. We see 3 tick marks, 3 tick marks. That means those two lengths are the same. So here's, don't write this just because it'll gum up your figure, but let's say I told you this length was 8. Well, now you know how long that length is because of notation, right? You know that it's 8 also. Alright, now let's do the same thing for angles. And let's use green. Okay, angles, we just do what we call an arc mark. Arc marks. And it's the same principle, where the same number of arc marks means those angles are congruent. Okay, so this is a very typical looking geometry diagram. So use arc marks to show angle congruence, or to show angles are congruent. Same number means equivalent. Same number means same size. Okay, this is going to save us a lot of writing. So give me some angles that we have marked as congruent. Okay, so angle A is congruent to angle D. One other one?
F and C.
F and C. Angle F is congruent to angle C. And then of course B and E also. Study this, know it. Here's an example of Y. Let's look at actually this bottom one first. So it says, what is HF? We want to know the length of this. Don't shout it out, but you can do this without writing the picture and just without a calculator, just by using notation. Okay? So I'm going to wait till I get a bunch of you with your hand raised, letting me know you know how long HF is. I already have one hand up. Now like 4 or 5 hands. Okay, keep going. 6, 7, 8. Okay. All right, go ahead and say, everybody. Okay, good. We see double tick marks with an 11. That means that this double tick mark is also 11. It's equivalent or congruent. And then we see a single tick mark up here that's 8, which means that is 8. And so this is 19 in centimeters. Okay, here's an angle example. This one's a little bit more involved. So it says measure of angle XWZ is 127. It just told us this whole angle is 127. And it wants to know YWV. So it wants to know this one. So you'll need a calculator probably on this one, but raise your hand again when you can tell me how big that angle is. Alright, good. I'm getting some hands up. Have about 6 or 7. Good. Okay. Alright, so this is actually combining the angle addition postulate with congruent notation. Before we even start, I said to label pictures. So where else can this go?
VWZ.
Good. Good job for using the angle name. Okay, so we have 32 plus x, or question mark, plus 32. In terms of the angle addition postulate, we have this statement. This becomes 64, and then we just subtract. So what'd you get for your angle?
36.
36?
63.
Yeah, it should be bigger. Okay. So congruent notation is your friend for sure, and you'll get so familiar with it that you won't even think twice after a while. So in terms of homework, and we do